So in this part of the question, we have a number consisting of 9-digit nines, and we want to place a division sign in between two of the digits to make a calculation. So initially, we have sort of 8 possible places I could put the division sign. Clearly, the number to the right of the division sign is going to have to be not bigger than the number to the left of the division sign. And so the only places I can really put the division sign are here, 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 or here. So let's take the first of these options. Let's go for here. So clearly, when I evaluate this calculation, I'm going to get a number consisting of 8-digit ones, and that's going to be fine. So this position is absolutely fine. What happens if I put the division sign here? Well, this number here consisting of 7-digit nines, we can write that in the following form. Now you'll notice that this number here, this number here, and this number here are all multiples of 99. So we have one big multiple of 99 plus a 9. In other words, if I divide this number here by 99, I get remainder 9. So this calculation here does not give me a whole number. Now let's look at the third position. So here, the number consisting of 6 nines divided by the number consisting of 3 nines, well, we can clearly write this number as 999,000 plus 999. And these are definitely both multiples of 999. And so this calculation is absolutely fine. And finally, let's look at the fourth position. So here, again, with exactly the same method, this number here is 99990 plus 9. This is definitely a multiple of 9999. And so when I divide this number by this number, I get a remainder of 9. So this division doesn't work. So I'm asked how many of these possible divisions do work as the first part of the question, and clearly the answer is 2. So we're also asked how many digits the smallest result of these calculations has. So to get the smallest number, I'm going to be trying to divide a number that's as small as possible by a number that's as big as possible. So that's going to correspond to the furthest position this way, which is this position here. And so I'm asked how many digits the result of the calculation 99999 divided by 999 has. The result of this is 1001. And 1001 has 4 digits. So we're now asked to do the same thing, but with a number consisting of 25-digit nines. And so before we jump straight into that, I think it would be useful to have a little look at the general case of what's going on here and what we really need to extract out of this question. So we're really interested in, if you have a number which has a bunch of nines, and we divide it by a number consisting of another bunch of nines, when is it true that this gives you a whole number answer? And so how do we even start thinking about this? Well, I think we want to tackle it in pretty much the same way that we did in the first part of the question. So let's take our number consisting of A-digit 9s. Now, in the first part of the question, we subtracted off multiples of this smaller number until we reached a number at the end that was smaller than this number, in the same way that you may have learned to do division when you were in primary school. So we can keep doing this until we end up in a position where we can't take off any more multiples of this. So this is going to give us that this number here is some big multiple of this number plus some number at the end, consisting of fewer than b digit 9s. So when do we get a whole number? Well, if we've got digit 9s left over at the end, then we don't get a whole number answer. But if, by doing this procedure here, we've managed to clear all of the digits of our larger number, then we are going to have that this number is a multiple of this number. And so what we've really found is that this number consisting of a digit 9s is divisible by this number consisting of b digit 9s if and only if this number a is divisible by this number b. So now let's apply this to part B of the question. So we have 2025 digit 9s, and we're going to split them up using a division sign into b 9s over here and 2025 minus b 9s over here. And the question is, how many ways can we do this so that this number is divisible by this number? Well, now that we've looked at the general case, we know that actually we're really saying how many choices of b are there such that 2025 minus b is divisible by b. And if you think about it, this is the same as saying how many numbers b are there such that 2025 is divisible by b. Because 2025 minus b is going to be a multiple of b precisely when 2025 is a multiple of b. So this is the prime factorization of 2025. And so to work out how many choices of b there are, we're really interested in how many factors does 2025 have. Now note that we can't actually take b equals 2025 because that would be like putting the division sign over here, which is clearly not okay. So we're looking at how many factors does 2025 have other than itself. And so any factor of 2025 is going to be of the form 3 to the alpha times 5 to the beta, where we must have alpha at most 4 and beta at most 2. And so this gives us 5 choices for alpha, 0, 1, 2, 3, 4, and 3 choices for beta, 0, 1, 2. But remember that we can't have 2025 itself, and so we can't have the choice where alpha equals 4 and beta equals 2. So there's 5 choices here and 3 choices here. So in total, there's 3 times 5 choices minus 1 for the 2025. In other words, we have 14 choices for what b is, and hence 14 choices for the result of the calculation. So in the last part of the question, we're asked for the number of digits of the smallest possible value of n, i.e. the smallest result of a calculation like this. So to get the smallest possible result, we're going to want b to be as big as possible. So remembering that 2025 is 3 to the 4 times 5 squared, we can see that the largest factor, other than the number itself, is going to be 3 cubed times 5 squared. Okay, so we need to work out what the result of this calculation is. When we let b equal 675. So actually we'll notice that this is the same as 2 times 675. And so this number is like twice as long as this number. So we now just need to evaluate this division. And so we can see from this representation that the result of this division is going to be a 1, followed by 674 zeros, followed by another 1, which means that the total number of digits is 676.